You're listening to Sheridanlife Radio.
Good afternoon, Sheridan College, and anyone else who may be listening. It is now time for Smacking Down Some Learning. Dare I say, the last one of this semester. Yes, cry, sob, get all your tears out. What will you ever do without my long ramblings of scientific topics? But fortunately, I do have to go home, and instead of me rambling about scientific topics, it will be me listening to my dad ramble about scientific topics, as it always should be, passing it down through the generations. Anyway, I am here today with...
Hi, I'm Carolyn.
And it is so nice to have you here, working at Sheridanlife Radio. Finally got you on here. Finally managed to track her down. Kidnapping is hard work, folks.
I know you asked me once last year, I believe, to come onto your show, but I think that was right after I pulled an all-nighter getting a final done, and I was like, oh, I don't think that's a good idea.
Yeah, I would never pull an all-nighter. I definitely was not doing homework last night until I heard the birds chirping. Nope, not at all. It doesn't count as an all-nighter until the sun is up. And if you don't look out the window, the sun's not up. Exactly. That's how it works. This has been science. But no, today we're talking about a different scientific concept than the detrimental effects of a poor sleep schedule, although I will do that one of these days, especially because it's rather important for college students to hear, I think. Cough, cough, my roommates. Guys, get some sleep, please. Anyway, today we are talking about lactose intolerance. This is a really interesting subject that covers kind of a wide range of stuff that I find interesting, that I've talked about before. Evolution, genetics, and, a little bit of cellular biology in there, if we want to really get into it, metabolism, all that cool stuff. I think it's going to be really interesting. So I gave you a list of topics, Carolyn, and you gave me 3, and then I picked lactose intolerance because that was the only one I actually knew stuff previously about. Fun fact, my twin sister is, or maybe was, lactose intolerant. I don't know. Sometimes she says that she's no longer lactose intolerant. I'm not sure if I completely buy it. I might be getting an angry text message from her. But I am not, probably. Maybe. Hopefully. I mean, I eat cereal every single morning, so I should certainly hope not.
I mean, I think, the body, first of all, in general, is very weird. But
yeah.
I mean, lactose intolerance might be different. You would know better than I do, but I know with some allergies, allergies will go away after 7 years for some people, or you can always develop new allergies.
Mm-hmm.
So that is strange.
But yeah, now lactose intolerance is a little bit different because, when you kind of hear about it, you think, it's like something that's aside from the norm, right? Normally everyone can process lactose just fine, and then there's a small subset of people who can't. That's not actually the case. Lactose intolerance is the default for human beings, basically.
Really?
That's how it started. Lactose tolerance is actually a genetic mutation that goes back about 10,000 years, which is a relatively short time frame for an evolutionary scale. So actually about 65% of the world's population is lactose intolerant, and then about 35% is lactose tolerant. And there's actually a geographical correlation that we'll get into in a little bit. But first of all, what is lactose intolerance? What's actually going on under the hood, right? So lactose is a sugar that we get a lot from milk, dairy products, and that kind of thing. And specifically mammals' milk, cow's milk, but also just any mammal's milk. And so every no, I'm getting ahead of myself. I'm getting too far into the evolution. Got to bring it back to what's going on under the hood. So lactose is a disaccharide, very fancy term for what is basically, it's 2 sugars stuck together. It's glucose and it's galactose, which kind of sounds like a Marvel villain, but I swear it's just a type of sugar. And so they're stuck together. And when you ingest lactose and you are able to process it, what happens is that there's this enzyme in your gut, in your intestines specifically, I believe. Maybe. Yeah, I think it's in your intestines. Called lactase. So that lactase enzyme has the ability to do a little bit of magic. I think it's hydrolysis, and if I remembered what hydrolysis specifically was from AP biology, I would not get into it here. It does a little bit of magic, and it splits the two apart, and, it's processed. It ships it off to the bloodstream, bada bing, bada boom, you've processed your lactose, and you can use it for nutrients, yippee. Good for you, right? Now, if you do not have enough lactase enzyme in your gut, what happens is that lactose goes straight through your intestine, and it actually builds up in your colon. It gets digested by bacteria in there, which, when they're fueled by all that lactose, they produce a lot more gas, like methane and that kind of thing. And so it can result in symptoms like bloating and stomach pain and diarrhea and that kind of thing. So it's essentially, it's not good, right? It sucks. And, some people, very mild lactose intolerance. Some people have, pretty severe lactose intolerance. But that's basically what's going on under the hood there. And the difference between, being lactose intolerant and, being able to process lactose is just a matter of how much lactase enzyme you have in your intestine. So what happens is, since all mammals produce milk to feed their young, right, you need to be able to process lactose. So all babies can process lactose. Well, there is a small subset of if you are born and you can't process lactose, like from birth, that's kind of a separate thing. But essentially, all babies are born with the ability to process lactose so they can get the proper nutrients from their mother's milk. But then as they are weaned off of milk, you kind of eventually lose the ability to process lactose when you hit adolescence, because the lactase is like, all right, my job here is done. I did my work. This isn't our sole source of nutrition anymore. I can sit back and relax. But then, unfortunately, human evolution didn't account for the fact that we're now using other mammals to get our nutrients from other milk, and we would like to do that past our adolescence, please. So, and it's really interesting, because that whole thing where, give cats milk, they love it. And then later on you learn, you're not supposed to give cats milk, actually, it'll make them sick. And what it actually is that you can give kittens milk, because they can still process lactose. But an adult cat will be lactose intolerant, most likely. So, we could give them a stomachache.
That's really interesting. But now I kind of wonder, is there differences, which I guess maybe is not a topic we should talk about on air, but, is there a difference in people on whether or not they can process lactose depending on whether or not they had milk or formula as a baby?
I don't think so. I believe it's more of a genetic component. When I was, looking into this before the show, I never saw any mention of milk versus formula, and I think there will be lactose in the formula regardless if it's breast milk or formula. Because, it's one of the essential sugars, right? So what it actually is a genetic component. If we want to get into it, I believe it's a recessive trait that's passed down. So you only need one parent with the dominant, lactose processing, basically, I make more lactase. That's a dominant gene. You only need one parent to do that to pass down to their kid the lactose tolerance.
Oh, so does that mean that in the future, let's say, the amount, because right now the majority is lactose intolerance. Mm-hmm. So does that mean, in the future, the amount of people who are lactose tolerant will continue to grow?
I believe so. Well, along with standard population growth, obviously the population will grow in that sense. Suppose, taking into account the fact that it's a dominant trait, it could very well be the case that, more people become lactose tolerant and that kind of thing. There isn't really, I'll kind of get into the evolution a little bit here. So, and I think that will kind of help answer your question a bit. So, back before I said that lactose intolerance is actually kind of the default. And about 10,000 years ago, everyone was lactose intolerant because they just did not keep up producing most of their lactase in adolescence. So what happened was, about 10,000 years ago, we see evidence of lactose processing past adolescence, showing up in like bones and that kind of thing. So we're like, well, why 10,000 years ago did some people like suddenly start being able to process lactose in these specific locations? So the short answer is we don't know. As is with most things, but the long answer is that, of course, there are several theories. So the short answer, the one that they kind of teach you about in biology class and that kind of thing, is that this gene was kind of a selective pressure when we started raising cattle. So in pastoralist communities, that's the vocab term that was thrown around in the research, basically communities that raised cattle for nutrients and that kind of thing. It was advantageous to be able to process all the nutrients from milk, right? Because it is a pretty good source of nutrients if you can process the lactose and not get any of the negative effects. So you'll see lactose tolerance is mostly in like Northern Europe and also some like smaller places interspersed through Africa and the Middle East. And these more isolated places will usually be pastoralist like communities where they raise cattle, and it's advantageous to be able to process lactose to get the nutrients from their milk and the dairy products. So the additional theory is what maybe happened for lactose tolerance become so prominent in Northern Europe is that when people kind of migrated up north to Northern Europe, they brought their crops with them, and then the first season hit and they're like, uh-oh, this is colder than we thought. So their crops didn't do as well as they thought they would, and it would result in famine, right? So in famine, you got a lot of starving people. They're going to turn to other methods of nutrition. And one of those methods of nutrition would be milk from cows, lactose, right? And, I mean, and this is a little bit morbid, but a starving person who is lactose intolerant and then drinks lactose, that's not going to be very good for them. So, essentially, if you've got a portion of people who can process lactose and a portion of people who can't, and they all, are trying to drink milk to survive, you're going to be left with only the people who can process lactose.
Okay, so there's a bit of like survivorship bias going on.
Kind of. It's the term is selective pressure in this case. Yeah, a bit of a environmentally fit, so to speak, right? And that's kind of one of the theories as to why that sort of evolution happened so fast. Because evolution, 10,000 years, pretty fast for an evolution timescale. And then, kept growing, kept spreading, right? It's a dominant trait, which is rather advantageous. I remember learning about, looking at different communities, like Northern Europe, you'll see variations of lactose tolerance in the genes, which is like, we think that these specific nucleotides in the DNA, these specific little sections, are the ones that are contributing to, producing more lactase. But then if you look in other areas, like in the Middle East or in Africa, right, they might see different genes that are still producing the same result, lactose tolerance, right? So it's a really interesting example, kind of like rock pocket mice and evolution. Oh my gosh, if we're remembering all the way back to that Smacking Down Some Learning episode, man, maybe I should redo that. It's been a while. I do like talking about evolution. But yeah, it is like a really fun and simple way to kind of demonstrate how traits can start showing up and adapt and change. And it's really funny, like, there's so much cheese and dairy products that we see over here in North America all the time. And, it's surprising to think about. Like, sometimes it surprises people to hear that, like, lactose, most people can't process lactose. So yeah, depending on like geographical area, like Northern Europe and some places below that will have lactose tolerance, about 35% of the population. And then, further east in Asia and that kind of thing, you're not going to see as much lactose tolerance because they just didn't have the selective pressure for that. They got their nutrients from other ways. So it's really interesting.
I know like my dad is Chinese, my mom is Korean, and I know like Korea specifically, like not a lot of cattle, a lot of seafood, not a lot of cattle, because there just isn't the space for agriculture in that, because cattle take a lot of land.
Exactly.
Take a lot of land. So especially like beef is very expensive there, whereas seafood is like the more cheaper protein option, which I think is like inverse to here, where seafood is like the very expensive, like high quality stuff that you get it like either on the coast or like it's imported and the import costs are crazy. But yeah, I can see that in areas where they just don't have cows, really, like don't have a lot of cows in their history, it wouldn't be a real concern for them on whether or not they can drink milk or not, or like cattle milk.
I think about like 90% of the population in China is not lactose tolerant. They're lactose intolerant, and it makes sense. They just never had to. It's just, and there's still that 10% of the population that can still process lactose, right? And it's a pretty interesting mutation to have, right? And it's such a small thing. Like some of it is literally just like 2 tiny pieces of DNA that get substituted, and that it's not even in the part of the gene that regulates and produces the lactase enzyme, but that difference in the sequence later down the line can affect how lactase interacts with other proteins, and it just results in you just keep on producing lactase through adolescence. There are actually situations, there's kind of like 3 types of like lactase, I don't remember the term, but just lactase persistence or something, I think is the term. But there's one kind of lactose intolerance where you're genuinely born with lactose intolerance, and then the best medical recommendation is to just avoid lactose altogether 100%. You'd probably have to get some specific formula or something like that. And then there's regular lactose tolerance, which is essentially I have the lactase to process lactose before adolescence, and then I just gradually lose the ability. And then there's lactose intolerance, where actually you can process lactose, but then you get sick, and that can damage the biome in your gut, and you'll actually lose out on your lactase, and you'll become lactose intolerant. And that, I believe, is reversible, though, which is interesting.
It really is interesting to think about a condition like lactose intolerance being reversible for some people.
Oh, now this is where we get into something interesting, right? Is that I had heard a story of someone cooking up a solution to lactose intolerance just by themselves, right? So I went and found it, and I watched the video. And so there's this guy, essentially, and at one point in his life, he suddenly became lactose intolerant, like really lactose intolerant, could barely process it at all. It would make him really sick. So then he went into biology. And so whenever someone asked him, oh, why did you go into biology? He responds with, I just really want to be able to eat pizza again, man. So what he ended up doing finally, when he acquired the skills to do so, and he filmed the video of this, The process is very interesting, and it kind of, like I said before, it kind of relates to the cancer vaccines, actually. But what he did was he took a virus that is kind of tried and true and tested within biology to kind of change around your cells a little bit. It's essentially a virus. What viruses do is that usually to reproduce, this virus is like an accompanied virus, so it's not going to make you sick unless it's accompanied by the virus that it usually comes with. So it's just a little secondary helper that just kind of hangs out in the body. What it'll do is that it'll get inside a cell, it'll inject its DNA sequence into the cell, mRNA, I believe, and it'll basically tell the cell, hey, stop the presses. I know you want to make your own stuff, but I've got this slip of RNA right here that says you should start chugging out these things. And the cell's like, what are these? And the virus is like, don't worry about it. And the cell's like, okay, because it can't tell the difference. So it reads the mRNA and it starts making more of the virus. essentially. It starts making a whole bunch of virus parts, and they, mash around and they collide together, and it makes more viruses, and then eventually the virus is like, all right, thanks so much for your help. Perish. And so I was like, all right, and it dies and it lyses and it releases more of the virus, right? So that's how it propagates itself, right? But what you can do is that you can modify the virus, its own genetic sequencing, so that instead of only its genetic code being propagated into that cell, you can, switch around that little slip of paper saying the mRNA should do this. And it'll hand over its mRNA. It'll tell the cell, hey, you need to make some more of this. And the cell's like, all right. And it takes the instructions and it starts turning out lactase instead, because that's the genetic sequence you gave it. So they use this kind of virus modification for lots of different things to kind of adapt your cells to different things, because it's basically telling it, hey, produce this. You're taking advantage of its own biological mechanisms to make the enzyme that you want it to make. Mm-hmm.
That, would you say that that's sort of in the same wheelhouse as, and I'm not sure if this is the right term, like biohacking, where I think scientists, which I don't know if this is something that would only work on adults or, older people, but I know with, pregnant women, and they're discovering, they can find out if the unborn, fetus will have some recessive, maybe, I don't think disease is the right word, but something that will, make them sick or might possibly make them sick that they can take out while it's a fetus.
I think there's, in terms of biohacking, I think that's kind of a different thing with some different connotations.
Okay.
Because there's also you'll just see online these guys on steroids just I'm biohacking and that kind of thing.
Okay, yeah. I do think that's what looks maxing.
Yeah. He kind of mentioned in his video of just I know that there's kind of a lot of stuff around biohacking and a lot of people doing a lot of really unsafe things, and that is absolutely true within the space. There's usually a lot of misinformation when it comes to medical stuff like this, but he's I'm going to show you the entire process, doing this in a very sterile lab. I'm going to tell you what the risks are and that kind of thing. He took an acceptable amount of risk for himself, and he says, if I'm going to refine this process, obviously it's going to be even more sterile and purified and preventing any kind of proteins from getting in there that I don't want. And then I think what you were referring to would be maybe CRISPR, gene modification and that kind of thing. And I can't recall if that's legal right now. I don't think it is. It gets into weird into weird and dangerous territory right now.
I do know it's
but this
very
is just
questionable.
Yeah. But yeah, this is just a grown man being I don't want to be lactose intolerant anymore, and I know exactly how to do it. I just need more of this enzyme, and I'm gonna employ the viruses to help me. Because it's basically what he does is that he makes the virus that has the sequence that he wants, that's going to inject into his cells, right, to make more of this enzyme. And he puts the virus into a couple pills. He takes the pills, he swallows them on camera, and then he's like, all right, see you in 3 days. And so 3 days later, the rest of the video is just him eating a lot of pizza. Because basically what happened was he ingests these pills, they go down into his digestive system, the virus is then released, and what it does is that it propagates himself in his intestine, in his intestinal cells, and so now these cells are producing lactase. And, enough lactase for him to be able to digest as much lactose as he wants, right? And it's, really, he's completely fixed his lactose intolerance. He says yeah, it's been a while and I'm still being able to eat cheese. And it's it's a really simple solution. It's kind of similar to insulin in the sense that we know what chemical we're missing. We just need to figure out a way to put it in.
Yeah, it is really interesting because especially when you made that insulin comparison, because there is no permanent insulin. It's you have to keep injecting insulin into your body. It's not just you take 3 pills and then for the rest of your life
Yeah.
you have that thing.
Like
you
injecting
need.
insulin would be kind of more comparable to like taking a lactate pill along with eating lactose, right?
Yeah.
There's like lactose-free milk out there that just contains lactase in it, so it cancels out. So you can like, consume lactase along with your lactose, and there's, they say like, oh yeah, that'll cancel out. I think that's kind of debatable. I think it seems to get the job done. Just like those lactate pills, just like you're providing yourself with some temporary artificial lactase. But in this case, he's not just giving himself lactase in a pill. He's giving himself the ability to make more lactase via the pill. Right? So it's kind of perpetual. Like if you didn't have enough insulin in your body, instead of just injecting more insulin, you inject something that will stay in your body and produces the insulin for you.
Honestly, that's pretty insane.
Right? Dude must have loved pizza. And honestly, can we blame him?
I mean, I'm lactose intolerant. It does not stop me from eating dairy products. I think I told you earlier, I got a bunch of free cheese last night, and I was just snacking on it in the dark. And I was like, well, I'm going to pay for that later.
I mean, you gotta, though. It's free cheese. I mean, there's a stereotype just like anyone who's lactose intolerant. Like, they do not act like it. They'll eat whatever cheese they want. And honestly, respect.
I mean, it hurts, but it's so good. It tastes so good.
Yeah, I don't know. I don't think I'm lactose intolerant. I don't know. Maybe I could be in the future. Maybe I'll get sick or something. But it can wear off. Or when in doubt, become a biologist and go through the entire chemical process of creating a virus to change it for you.
I mean, both my parents are lactose intolerant. Their parents were. I don't think it's ever changing for me in the future. But if this pill ever goes on market or is able to be purchased in some way that I can afford, I'm getting it, and then I'm getting like 3 tubs of non-flavored Greek yogurt, a bottle of honey, and a spoon, and don't bother me for 48 hours.
Oh my gosh, so real. I guess in the meantime, what you can do, get some Lactaid and see if that works.
But that's so interesting. I wonder now, I guess, what would the ramifications be of, I guess, because he's an adult taking this pill. Would there be issues with, like, a child taking this pill? And then, I guess I'm wondering, like, just because I saw recently, like, I'm comparing it to a situation I saw recently of someone who was taking, like, a cisgender man who started taking testosterone, but he started before he went through puberty, and as a result, his body stopped producing its own testosterone, even though he's a cisgender man, because he was getting it from an outside source. So now I kind of wonder what the ramifications would be of taking this pill before puberty, and whether or not that would affect it in any way. I feel like...
I honestly don't know. Like, because it could also depend on just, like, would they be lactose intolerant in the future, or did they already have the lactose tolerance and they're just taking it for no reason? It's kind of an interesting question, actually. Like, too much lactase? I don't know, because it's kind of weird, because again, I feel like it would be something like, just like, I'm an adult and I'm gonna take this understanding the risks, instead of just like, here, this magical pill will cure everything. It's like, listen, kids, don't do drugs.
I mean, I'm definitely thinking for, like, infants who are born with lactose intolerance and they can't have breast milk or, common formulas, they have to get special ones without lactase. So I wonder if that, like, in instances like that where it would be really beneficial.
I don't know. Because again, it's just one guy making it in a lab, right? So,
where's
that's an
his money?
Where is
get
his
him
money?
some money.
Come on,
Let's start
we all
doing
wanna eat
trials,
cheese. It's so good. Yeah, but it is pretty interesting. Like, and they do like use it as an example in like biology a lot of just like, oh, this is evolution that has happened in humans that you can see today of just like how these traits are different just down to the digestive system. It's super interesting. And like introducing selective pressure in terms of just like, oh well, what portions of the population might have had a need to get more of their nutrients from something with lactose in it and that kind of thing.
I do think it's also interesting to see that because it is like a beneficial perk to be tolerant of lactose, something that we can find in every grocery store today, right? That it's a dominant gene. And I feel like that's, I don't know what the opposite of like natural selection would be, but like traits that help us survive.
It does make it easier to pass down.
Yeah.
Yeah, I think the term would be like, oh, this organism is environmentally fit for its situation, so it lives longer to reproduce more, in a sense. That's kind of what the two main selective pressures in evolution are. It's just like either you don't die before reproductive age, or you're like really attractive to the other members of your species, which means you propagate more.
Listen, it's been a long time since I've been in any sort of biology class, like over 10 years ago, and the only thing I remember is the Galapagos Islands.
Honestly, fair enough. Shout out to those finches.
Gosh, but...
I mean, we're at art school,
Yeah, yeah. I think... Well, first of all, if I have to say, like, what my main takeaway from this would be, it would be that I'm normal and you milk drinkers are the mutants, number one.
New X-Men storyline, when? It's like, I shoot lasers out of my eyes. I can control the storms. Me? I digest lactose.
New team member up there with Wolverine, for sure.
Exactly. The cheese eater.
Oh gosh, I feel like we can definitely come up with a better name than that.
Listen, man, I'm trying my best. I was lying when I said I got sleep last night.
I mean, what is it? I have to say, like, just completely off topic, I think my favorite, I guess, not superhero, he's not a superhero, but, like, comic name would be, like, the Condiment King, and he just, like, shoots people with mustard.
Dude, when can we get that guy on air? Let's interview him for sure.
I mean... I guess if you know that, like, being lactose tolerant is a minority of the population, and if you wanted to be an evil villain, you could just go around and, like, shoot cow milk at people. Throw cheese at people.
It's over, Batman. I, the Condiment King, have finally invented a cream-based condiment, and I know there's a 65% chance you're lactose intolerant.
God, what does ranch have cream in it? Is ranch dairy?
I think it does. I remember, like, when he was filming, like, the pizza that he ate, I'm just like, okay, this is my first pizza after the treatment, let's see what happens. Like, they kept talking about how it had ranch on it, so I think it is cream-based or something. I was like, it's over, Batman. I've collaborated with the Ranch Riddler.
I think for sure that, I think, yeah, if I suddenly was able to be lactose tolerant, I think the first thing I would eat, yogurt. But I think pizza would be a very close second.
Oh, heck yeah. Dude, cheesy garlic bread.
Ooh.
Chef's kiss.
Ooh.
That's some good stuff.
That does sound really good.
Mm-hmm.
It's really bad I live by a pizza place now.
Oh, that's so awful, dude. That's like psychic damage to anyone with lactose intolerance. But, what's gonna stop them, really?
I mean, I feel like I won't live that long, but, like, seeing where this evolution goes in, like, another 10,000 years from now. If humans are still around.
It honestly might just stay relatively the same ratio, honestly. Who knows? Or maybe just, like, the lactase virus, might be a common thing. Or, maybe people will just, like, take more lactase with their food and that kind of thing. Or, maybe all the cows will go to space and leave us on Earth, jump over the moon, and we're going to have to find something else.
Well, I do think that the rise in, like, veganism, especially, Like, people are definitely staying away from animal products more and more. I think people are realizing that at the rate that we are right now, our agriculture practices is really damaging the planet, you know? Especially, like, just the amount of, like, methane gas that, you know, cattle produce.
Like, we farm so much milk that it's actually a waste product, and so a lot of it is broken down, and the lactose sugar is used in a lot of different foods. So, you know, this guy who was curing his lactose intolerance, he was talking about just like, yeah, there's lactose sugar in a whole bunch of things. There's also like whey, which is a dairy byproduct, and all these sorts of things that you wouldn't think that would have lactose in it, but it does. So I've had to find a bunch of alternatives. So yeah, we just produce that much of it.
I wonder how comparable lactose intolerance is to, like, celiacs, for example, or like wheat gluten intolerance as well.
Celiacs is far more severe for sure. Like, that's
definitely.
like an allergy.
Definitely.
Like, that's, I think, an immune system response. Allergies kind of are. And then gluten intolerance, I believe, would be kind of similar in the sense that, it just doesn't digest very well. Probably the sugars within it just, you know, like, don't break down, just like lactose wouldn't break down. Then celiacs is extremely severe, so like less of an intolerance and more of just like, do not come in it.
I know one of my exes had celiacs, and there were definitely instances where we would go to a restaurant and we'd have to be so careful, because even if the glass had been washed, if it previously had beer in it, like a wheat beer in it, and he drank out of that glass, even if it had been cleaned, he would still get sick.
Yeah.
It is very, very severe.
Maybe one day we'll do an episode on allergies and kind of like what induces that. You mentioned, do they really turn over every 7 years? You know, what kind of immune system response is happening there? Why does the body identify these substances as dangerous? And why does it decide that the only way to survive is just to make its own health worse?
I mean, I knew one of my previous coworkers, actually, she had a bunch of allergies to like berries, nuts, different kinds of like tropical fruit as well, like a lot of different allergies. And she was recommended to go on a natural, like, vegan diet. And within 2 weeks of only eating vegan, she was able to like start consuming certain nuts.
Huh. That's really interesting. Like, I'd wonder what the biological reason behind that would be. I mean, I'm no nutrition specialist. I'm really more into, like, the cellular biology stuff, so I wouldn't really know what would be happening there. But that kind of stuff is interesting. Just, like, what kind of changes are happening there? But yeah, in this case, like, lactose intolerance, like, you can, you know, use a virus to change your gut biome because it's not a reaction to the lactose. It's just a lack of an enzyme that you need to process it. So it's just lactase or no lactase.
Which I think my second takeaway would be that bodies are just weird.
Bodies are weird. They're so weird, dude. They're so weirdly designed. There's so much junk DNA. There's so much stuff that we don't know what it does. Everything is so roundabout because evolution is just a series of random chance and weird luck and, you know, bare minimum adaptations for whatever the situation called for a bajillion years ago. It's kind of crazy how far that has taken us.
And I mean, even like when we were talking about like going back 10,000 years and looking at, you know, what happened there with evolution, it's all that we have our theories.
Yeah.
So who knows if in the future we might have something more concrete. I mean, it was only recently that more evidence came out that, because I know originally the belief was that, like, oh, women were gatherers, men were the hunters in, like, prehistoric times, but they're finding more and more female skeletons with weaponry and with, like, marks from hunting. So I think pretty recently it's been coming out that, like, yeah, women were also hunters back in those times, you know.
Yeah,
we're always
human
just getting...
populations are changing all the time, right? And the environment is changing too. And even we aren't immune to like the slow adaptation over time to our environment and that kind of thing. And so it'll be interesting to see just like what would that look like 10,000 years from now? Would we be the same? Because a lot of our modern technology means that we don't have to worry as much about selective pressure, which is amazing, right? Because back in the day, if you were lactose intolerant and all you had was lactose, like that sucks for you, right? But now we have so much amazing technology that we could do, just like lactase or like other nutritional alternatives and that kind of thing, where you get a fair shot. So we don't have to worry about that kind of selective pressure affecting us anymore. And yeah, so like it might, the ratio might stay the same, and some people just like cheese more than others. And honestly, keep making cheese, folks. It's good stuff. But yeah, it's kind of interesting to see how that showed up, and it's a common part of the lesson in biology. Just like, here's an example of a trait that's from a mutation in humans, right? So like, oh, you guys are all lactose tolerant. Well, that's a mutation, right? It's interesting stuff.
Mm-hmm. Feel like now every time I see you in the hallway, I'm gonna say, "Hey, there's my favorite mutant. How are you doing?"
New X-Men plotline. You can't give away my secret identity. Mm-hmm. I think we've said all we can say about lactose intolerance. Thank you so much for choosing the topic. I'm glad you were interested in it. And I believe that is the last episode of Smacking Down Some Learning for this semester, but hopefully I shall be back in the coming summer months. I'll be back at SLR. I promise.
Mm-hmm. Amazing. Thank you for having me.
Yeah, thank you so much for coming on. It's been a pleasure. Thank you so much for listening for this episode of Smacking Down Some Learning. I have been Devon Mitchell, here with
Carolyn Chang.
Mm-hmm. And we will see you perhaps in the summer. Thank you so much for listening. Have a great day. Recording will be up on YouTube sometime soon. Take care. Don't get struck by lightning. A lot of thunderstorms happening. Goodbye.